Hello everyone. Today we will discuss cycloconverter. As the name suggests, cycloconverter. That means it will give you output voltage at different frequency. So it is one kind of AC to AC converter which converts input power at one frequency to output power at different frequency. There are other ways also to obtain different frequency output voltage from AC input. That is, from AC you first convert it to DC using rectifier, then DC voltage is converted to AC using inverter at different frequency. As the function of inverter is to give you control over output voltage as well as frequency. If you want more output voltage, then at the rectification stage you can use DC to DC boost converter. So there are three stages. First stage AC to DC, second DC to boost or buck DC, and third stage is DC to AC. So three stages are there. Because of that one, in every stage some losses takes place. So the efficiency of complete system is reduced. But in cycloconverter, in single stage you will get desired output frequency. So efficiency of this cycloconverter is more than the three-stage converter. But there are some complexity in this cycloconverter. Let's discuss those things. Let's discuss some application and importance of this cycloconverter. It converts input power at one frequency to output power at a different frequency in a single stage. These are of two basic types, step up and step down cycloconverter. Based on the input and output voltage, it can be single phase step up step down or three phase step up step down cycloconverter. Nowadays these cycloconverter are becoming popular because of availability of high frequency power switches like MOSFET, IGBT. But for high power application still thyristor is used. So at high power application, cycloconverters are used at low frequency. We have discussed dual converter in single phase rectifier circuit. There we have seen that two converters are connected back to back and produces same output voltage. But the same converter can be used as cycloconverter. We will discuss it. Major applications of cycloconverters are low-speed AC motor drives ranging up to 15,000 kilowatt, very high power, with frequencies from 0 to 20 Hz. Then in this case, thyristor is most suitable switching device. Other applications include induction heating, static bar compensation, etc. Let's discuss about step up cycloconverter. The working principle of step down and step up cycloconverter are similar. Once you understood this step up cycloconverter, you can develop step down cycloconverter also. So there are two basic types, midpoint type and bridge type cycloconverter. This one is your midpoint type cycloconverter and this is your bridge type cycloconverter. Let's discuss this one first. In midpoint type cycloconverter, here you can see there is a three winding transformer. This is your primary winding and these are your secondary windings. And the turns ratio 1:1:1. So if the input voltage is Vm sin theta, then here also it will be Vm sin theta and here same voltage you will get. And the polarity of the output voltage also will remain same. If you want to increase the output frequency, that means suppose here you are giving 50 Hz input voltage supply you want 100 Hz output frequency across the load. Then within half cycle of input voltage, you have to complete one cycle of output voltage. That means within positive half cycle, you have to obtain positive as well as negative half cycle of output voltage. Then you have to use these bidirectional switches. Here, triac can also be used, but for simplicity, I have taken thyristors. So, in positive half cycle, this thyristor will conduct, and negative half cycle, this thyristor will conduct. Likewise, here also, in the positive half cycle, current will flow in this direction, then thyristor number 4 will conduct, and in the negative half cycle, 3 will conduct. So, we have to arrange the gating pulses of these thyristors in such a way that in one half cycle of input voltage, we have to obtain one complete cycle of output voltage. That we will discuss. Now, in case of this bridge type cycloconverter, this is nothing but a dual converter. We will use this dual converter as a cycloconverter. Here you can see input voltage across converter number 1 and input voltage converter number 2 are same, Vm sin theta. This is your nothing but rectifier. This one rectifier. Based on the type of the load, firing angle more than 90 degree you will get negative output voltage. Firing angle less than 90 degree you will get positive output voltage. Now suppose for positive half cycle at 30 degree firing angle 1 2 will conduct, then at pi plus 30 degree 3 4 will conduct, and you will get positive output voltage across the load, and the polarity across this point will be positive and here it is negative. If the firing angle of this converter is kept same as 30 degree, then output voltage you will get here and the current will flow in this direction. So you can see that for positive half cycle, if you are operating this converter, then this positive voltage you will get, and when you are operating this converter, this voltage you will get. That means negative output voltage you will get. So in positive half cycle you can obtain positive as well as negative output voltage. Now we will arrange this positive and negative output voltage in such a way to obtain one complete cycle in one half cycle of input voltage. Let's discuss one by one. Let's start with midpoint type cycloconverter. Here, in positive half cycle, we want one complete cycle across this load. So, in positive half cycle, the polarity of the secondary winding voltage is positive, negative, positive, negative. Now, favorable condition is there for thyristor number 1. So, we will trigger this thyristor number 1 and current will flow in this direction. So, positive output voltage you have got for some duration of time. Then we want negative output voltage for the same polarity. Then what we have to do? See here. If we are making our thyristor number 4 on, then current will flow in this direction. So the polarity of output voltage here is positive, here negative. That means input voltage is positive, but output voltage positive, negative, and here it is opposite output voltage we are able to develop. And as it is a AC signal, so average should be 0. That means area in the positive half cycle must be equal to area in the negative half cycle. So we have to arrange this gating pulses in such a way that average output voltage across the load you will get 0. So there is a condition here that for some duration of time this thyristor number 1 is on, then you have to make it off by force, that is known as force commutation. You have to make this thyristor off using some commutation circuit or apply reverse voltage across this one, or something else you have to do to reduce this current less than the latching current. Then the thyristor number 1 you have to make off. Then you have to turn it on. Then one cycle of output voltage is complete. Likewise, in the negative half cycle, SCR 2 and 3 will be on in negative half cycle. The polarity in negative half cycle, it is negative, positive, just opposite to this one you can see. Now you want positive as well as negative output voltage across this load. So what are the favorable conditions or which thyristors you can turn on? So you can see the thyristor number 2 here can be turned on. Provide the gating pulse to this thyristor number 2 for some duration of time, and then you can see we want negative output voltage across the load resistance. So when thyristor number 2 was on, you have got the current like this, and the output voltage polarity you have got positive, negative. Now in this case we want negative output voltage. Then to get that one, you have to make thyristor number 3 on. Then current will flow in this direction and the polarity will be developed like positive, negative across the load resistance. So in negative half cycle also we are able to develop both positive as well as negative voltage, and we will arrange this positive and negative voltage in such a way that average output voltage will be 0. Then only we can say our output voltage is AC. That means duration of on period of 2 and duration of on period of 3 must be same. At the same time, output voltage developed because of this 2 must be equal to output voltage developed because of this 3 and opposite sign. Then only we can say our output voltage is AC. So let's develop switching pulses in such a way that from 50 Hz input voltage we will get 100 Hz output voltage. Then we can say this is the step of cycloconverter. That means we are increasing the voltage from 50 Hz to 100 Hz. That's why it is a step of cycloconverter. Let's see. Here is our AC input voltage. In the positive half cycle, you can see thyristor number 1 is on for 90°. Then the thyristor number 1 is to be turned on by any suitable commutation circuit. So when 1 is on, it will follow the input voltage. So you can see this is exactly same as this one till 90°. Then after that 4 is turned on. So 4 is turned on, so you are getting negative output voltage. This one. You can see in the positive half cycle, when 1 was on, this voltage you have got positive output voltage. This one, this voltage you have got. Now when 4 is on, then the direction of current is reversed and positive, negative, opposite output voltage you are getting. So this voltage you are getting, negative output voltage. So you can see from here to this point, from this point to this point, it is one complete cycle of output voltage. Here positive half cycle and here it is negative half cycle, and it is similar in nature. So we can say average output voltage is 0. So it is a AC output waveform. Next, now the input negative half cycle starts from here till here. So in the negative half cycle, we want similar output voltage. That means though the input is negative, we want positive output voltage. So to get that one, 3 is to be turned on. You can see here the input voltage is negative, and when 3 is turned on, you can see the current will flow in this direction. So this positive negative output voltage you are getting, just like this positive negative. So positive half cycle of output voltage we have got by using this thyristor number 3. Now let's see. After 3 we want negative output. Though the input voltage is negative, we want negative output voltage. So 3 is to be turned off and 2 is to be turned on. Here when 2 is turned on, the current will flow in the opposite direction and the output voltage you will get here positive, here negative. That means this negative half cycle you will get from here. So two complete cycle we have got by using 1 4 and 3 2. So in one cycle of input voltage we are getting two cycles of output voltage. So the output frequency is twice of the input frequency. So likewise we can use this technique to increase the frequency of the output voltage. And one thing also you can measure that here the frequency is 50 Hz, so the time duration is here it is 20 millisecond. You can see start from 20 and here it is 40. So 20 millisecond and here it is 20 to 30. So 10 millisecond is there. So exactly 100 Hz output frequency you have got. Now from this discussion, one problem we have seen that when thyristor number 1 was on, then we have to make it off. Then we have to turn the thyristor number 4 on. So it is to be commutated. So this is one of the problem of this cycloconverter. And it is to be taken care of by using suitable commutation circuit. And because of that one, some voltage stress across the switches or switching losses across the circuit increases. As at high voltage you have to turn it off. So V square by R is equal to switching loss across the thyristor. R is the resistance of that thyristor. Now let's see step of cycloconverter using dual converter. We start with AC positive half cycle. In the positive half cycle we want positive as well as negative output voltage. So how you will get positive output voltage? So you just make 1 and 2 on. You will see here it is positive, negative. So 1 and 2 will be on. Then here you will get positive and here it is negative. So positive output voltage you have got. Now in the positive half cycle itself you want negative output voltage. Then turn off these two thyristors and go for this thyristor number 5 and 6 because here it is now positive and here it is negative. So favorable condition is there for thyristor number 5 and 6. Give the gating pulses to these 5 and 6. You will get current in this direction and the output voltage polarity will be positive, negative, opposite to the previous one when 1 and 2 was on. So this output voltage is reversed. So in one positive half cycle you are getting both positive as well as negative output voltage. So one complete cycle of output voltage you have got. Let's see. Here the input voltage is same, Vm sin theta. Now in positive half cycle we want this positive output voltage. To make this output voltage positive, you have to make this thyristor number 1 and 2 on. Then to get negative output voltage, you have to make this thyristor number 5 and 6 on. Then you will get one complete cycle of output voltage, just like midpoint type cycloconverter. Then in the negative half cycle, you want positive output voltage. That means now here it is negative, here it is positive. Negative, positive. So negative, positive. Then if you want positive output voltage, then negative, positive. So this positive is across this point. So this point is positive. Then the favorable condition is for thyristor number 3 and 4. So you make thyristor number 3 and 4 on, you will get positive output voltage. And to get negative output voltage during negative half cycle of input voltage 7 and 8 on, then you will get negative output voltage. Positive here, negative here. So in negative half cycle of input voltage also you can get one complete cycle of output voltage. So we are able to successfully develop a cycloconverter having frequency twice the input frequency. Based on this principle, you can increase the frequency of the output voltage. So this kind of converters are known as step of cycloconverters. Suppose you want to decrease the output voltage frequency, and from 50 Hz frequency you want 25 Hz output frequency. Then in one complete cycle of input voltage you will get half cycle of output voltage. Then thyristor number 1 will be on for complete 120 degree. Then in the negative half cycle of the input voltage you need positive output voltage. So to get that one you have to make, you can see, in the negative half cycle you want positive output voltage. So negative half cycle positive output voltage you will get using thyristor number 3. So for 180 degree you make thyristor number 1 on, and for 180 degree you make thyristor number 3 on. Then you will get this kind of pulse. This pulse, then again this pulse will repeat. So this will be your from 0 to 360, it will be half cycle of the output voltage. And then in the negative half cycle you will get the pattern like this using thyristor number 2 and 4. So like this, then this one and this one. So you will get one complete cycle of output voltage, and every output voltage of this obtained output frequency you will get 0, and the output frequency is 25 Hz. So you can try for this one and obtain. So I'm not going to discuss step down cycloconverter. Likewise you can use here also to obtain same 25 Hz output voltage. That means step down cycloconverter. So today I have discussed about cycloconverter, which converts input power at one frequency to output power at another frequency. And if the frequency of output is more than the input, then it is known as a step up cycloconverter. And if it is less, then step down cycloconverter. One problem of cycloconverter is that the switches you have to commute it. You have to turn off the switches by force. That means forced commutation is to be there. It is naturally AC input voltage is not coming to turn off the thyristor. One of the problem of cycloconverter, because of that one there are switching losses across the cycloconverter. Nowadays the cycloconverter are becoming popular because of availability of high frequency switches, because we can get different output frequency in single stage from AC input. Thank you.